We talked about the integration before, and we took first two cases, which is addition, subtraction, and composite, and integration of multiplication, simple and non-simple multiplication. Today I'm going to talk about the third case, if we have a rational function, integration of rational functions. Of course, before any integration, as I said before, you have to make sure that the function is ready by taking away powers of denominator, radicals, and identities. Trigonometric functions are also if they exist in denominator. Now, if after making the function ready, you still have a rational expression or rational function, then if the denominator is linear, then the integration will be immediately len. And actually it will be len absolute value of the denominator. And absolute value because we all know that domain of len should be positive. And of course, don't forget to divide by the coefficient of x. And if the denominator is not linear, then you have to go to substitution method by assuming that the denominator is equal to your assumption u. Of course, there are other cases, but I'm not going to talk about them now. There are other ways like partial fractions and integration by parts that can be used, but these are not our focus point here. So I'm going to keep talking about only if it's linear or non-linear here. Let's have a look at this example, for example. Let's say we have integration of 12 over 2x plus 1. First of all, is it ready? Well, look at it. It is ready because the denominator does not have a power to be taken up. It's not like 1 over x or power of 7. So it is ready. 12 here is a constant that can be taken out. So this will be immediately 12 outside the integration. And integration of 1 over 2x plus 1, that's linear, so immediately len absolute value of the denominator, always divide by the coefficient of x plus c, and that's it. Simple and direct. Of course, 12 and 2 can be simplified. So by 2, that's 1, by 2, that's 6. If you want to go by that, after simplifying, you can use properties of len to rewrite this as len 2x plus 1 all to the power of 6 plus c, and you can remove the absolute value here since power of 6 makes sure that everything is positive. So I can write it this way if you want. Now, the second case, when denominator is not linear, this function is ready. There is nothing to be done here. No power of denominator that can be taken up, no rational, no radicals, no identities, nothing. So immediately what should I do? Let's have a look at this again. If denominator is not linear, then use substitution where u is the denominator. So I'm going to use substitution here. U will be equal to denominator, so 2x cubed plus 1, and then you need to divide 6x squared, then dx equals du over 6x squared. This means my integration will become 12x squared over u times du over 6x squared. Simplify, this will be 2 integration of 1 over u du, since x squared with x squared, 6 with the 12, so it's 2 over u. What does this mean? This means that we have 2 times, now we have integration of 1 over u. U is linear or directly from the third rule, so it's 1 len absolute value of u plus c. Now just replace u, 2 len absolute value of what was u, 2x cubed plus 1 plus c. And again, we can use the properties of len, so the 2 can be taken up if we want from properties of len. So this can be written as len 2x cubed plus 1 all squared plus c, and in this case again I can remove the absolute value since a square makes everything positive. Okay, now what about the fourth case? If we have integration of logarithmic function, what can I do? In this case, if len exists in an integration, then immediately use substitution where u should be the len itself. Of course, I'm going to talk about natural logarithmic function. Well, general logarithmic functions are not far from this, but I will keep this discussion later on. So let's try to do an example on this. For example, if I have integration of len x over x times dx. According to what I have just said here, whenever you have len inside the integration, then immediately go to substitution and u should be the len itself. So in this case, u will be equal to len x. Now what did we say the derivative of len is? Derivative of len is derivative of what's inside over what's inside. Cross multiply. What will you get? Dx is equal to x times du. So go back to your question. Integration of u over x times x du. Instead of len, we have u. Instead of dx, we have x du. So if you simplify, x with x cancelled, so that's directly integration of u du, which is u squared plus c, and u was len, so this is len x all squared plus c. Simply, these are the cases of integration. Later on, we'll work on some examples. Let's have another question, and I'll keep this question for you. Let's say that we have integration of 2 over 2x plus 3 dx. Try to do this by your own.